So we've come up this road in quest of our waterfall at our next stop, and here we are. Some of the drive up here, the creek was just looking like a swamp, wetland, and here it's, you know, making some noise. Over here, next to the little road that we're walking on, we've got some rather chunky looking rock. We will see more chunks like this down at the falls where we're headed. And if I'm quiet, you might be able to hear the falls. That's where we're going next. So we've reached that spot in the road where you just kind of got to go over the side. And here's the creek down there, and somewhere down there we can still hear the falls, but not yet see it. All right, we're down at the creek, or I guess technically the South Fork of the Alsea River. And I'm looking upstream right here, and whoops, there we go. So there's, as far as I can tell, that's the biggest part of the falls, or at least the sheerest drop. On the other hand, it's not the loudest sort of hiss of rushing water that we've been hearing in the background, I don't think. So we'll look around here a bit, but continue on down the creek river, just a little bit at least. See if we can kind of figure out maybe what's going on. But what we want to try to understand at least a bit here is what the heck's going on. Like, specifically, again, we've had this subdued topography up from us, around us, and associated with that thick red soil that we saw earlier. And this here is at least part of the reason that we've got this landscape is hung up on, well, what appears to be more than one waterfall, but this is the first that I know of. So we want to look at what's the rock here, how is it being eroded, and what makes it so special as to be part of what's holding up an entire landscape upstream of it. So here we are, just past where I was before I was standing right up there, and now here we're just downstream of it looking up at the waterfall. And I'm sitting on a boulder amongst a pile of boulders at the base of this falls. Now, what I want to look at a little more closely is, again, what's the deal with the rock? Can I, we've got some nice rock exposures over there, and maybe even over there, that we can look at things like, well, what's the joint spacing of the rock? How is the rock being eroded? That is particular. We want to look at whether the rock could be eroded by abrasion, that is sort of little crystal by little chunk by grain of sand, etc., or whether it would most likely need to be eroded via plucking or quarrying, in which the stream has to pull out and transport big pieces, rocks, big boulders, and therefore the rate at which it can do that is going to be limited, in part at least, by the joint spacing. And we can get something of an idea of the joint spacing simply by the fact that we're sitting on these boulders, or I am, and Logan is. So, hey Logan. So Logan's sitting on a boulder, and that gives us some concept of what the joint spacing is like. Here's a bit of a view downstream. Okay, now it sounds like that loud hissing is behind us, so I guess this is the spot. That was my recollection as well, so good. All right. It's not clear what aspect of this falls is making the loudest hissy noise. All right, we're gonna go down to another spot, some of those spots I was pointing out before, All right, so we're here at next to the waterfall, but at a similar point where we've got the sheer rock here. And specifically, I wanted to look more carefully at these joints, because the spacing of these joints appears to be a limiting factor on how quickly this waterfall, this nick point as we call it, how quickly it can erode, how quickly it can move upstream. Now the rock itself, this is maybe still not the best place to get sort of an up close and personal of the, you know, how crystalline is the rock, how big are the crystals, that kind of thing. It's still pretty covered in moss, but it is a good place to get a sense for just how, it is a good place to get a sense of how big the blocks are. So we're just doing a little pan shot from the waterfall to this big pile of boulders just below it. One of the things you can notice here, except not from where the camera is right now, but okay, yeah, there's this sheer rock face back there, big pile of boulders here, and what I can see, but I'll show you in a bit, is that there's like another little step in the waterfall just down here. Interestingly, it's not a step in, it does not appear that the step is formed by intact rock, rather the step is formed by these boulders. So the rocks are coming out of this little short cliff here, they're piling up, and they're essentially forming a second waterfall because they're not moving very quickly. So the rate at which these boulders can move is a fundamental control on how fast this waterfall can retreat. The sooner these boulders are gone, the more, the bigger this cliff behind us will get, the easier it'll be for the stream to rip more boulders out of it. Right now, these boulders are kind of holding things up. We were talking, Logan and I, earlier about, so what makes this so different from other parts of the Coast Range where we have sandstone, where the bedding, where the joint thickness is not all that different from here. So what makes this erode so slowly relative to those? If they're both eroded by ripping out blocks, then why would this one be moving so much more slowly as to create this subdued landscape and the 4-meter thick soil that we see up there? And kind of what we come up with, maybe it's right, maybe not, is that, yeah, the Tyee is somewhat massive in places, but it's still crap. And so once it breaks out, it tends to get pretty crumbled up pretty quickly. So it's going to break into smaller pieces. The jagged edges are just going to disintegrate really quickly at the first hint of a stressor, and those boulders are just going to break up much more quickly than these. So even if it takes a similar sort of impulse to rip the boulder out in the first place, which maybe it is, maybe it isn't, but once it's been ripped out, these boulders are just staying exactly the same size they were before. And we were noticing this boulder down here that looks just like if we were doing a 3D puzzle, then it seems to fit real nicely back in the notch that we were spotting up in the sheer face of rock up there. And so it seems likely that, yeah, well, whether it is or it isn't, whatever rock got ripped out there probably hasn't moved any farther than that one, and that's as likely a candidate as any for what came out of that particular spot. If we wanted to get real fancy, maybe we could do some sort of examination for looking for exotic cosmogenic isotopes in some of these rocks maybe we could get a sense for how long some of these boulders have been sitting here. Um, there are kind of some fundamental problems with doing a study like that, like, well, what if the boulder turns over? So, but worth thinking about anyway. So I'm on the pile of boulders. There's Logan. And here's a sort of secondary falls here. And the reason that I wanted to show you is just, all right, these are boulders. This is a pile of boulders forming a secondary falls. And you can see it continues on around here. So the rate at which these boulders can be moved is clearly inhibiting the rate at which this stream erodes the rock. Now, if I move up here, we can look further downstream and see this bunch of boulders continues to litter the bed of the stream on down a ways, and we can see a number of steps. Whether those steps are in bedrock or boulders, I don't know. Boulders seem to be enough, though, to hold up this section of stream and keep it really steep. So even if the one behind me is the only bedrock nick point, the rate at which these boulders can be moved through here is looks to be pretty severely limiting the rate at which this stream can cut. And we can see the very steep slide slopes on either side here. Some of these boulders are likely to be coming in from the side. So you can see the sort of pile of boulders that tails up onto the hillside there. It seems likely, or at least possible, that some of these boulders are simply breaking out of the sides of the valley. So we've come down a step. There's just the view downstream, and we're up against that lower step that we were just looking at.
I'm at the elevation of that.
And yeah, so Logan's at the elevation of what looks to be, now that we're down here, or now that I'm down here, I'm pretty sure now I'm looking at intact bedrock. I can see the jointing, and some of those joint spaces are relatively large. It kind of gives the illusion, and maybe over there, maybe it is actually a pile of boulders, but right here we can follow that rock face on around to the one I'm standing right next to, which is the bedrock in the valley wall, and that's not a very good view of it, so I'll back up in a sec. All right, let's try that again. So there's the rock face. This would be the sort of second step, at least in the bedrock of this falls. And then as I look over here onto the stream right, that is river right of the valley, you see the sheer rock face. And that's a good 2, 3, 4 meters big hunk of rock. Now, last year when we were here, I didn't know what kind of rock this was, and I'll give credit where credit is due. Chuck Lewis helped me figure out what this stuff was. It's hard to break it, but I've broken a little bit here, and I'm going to pause so I can zoom in on that. Like I said, this rock is hard to break, and so I broke off a little chunk there. There's my glove for scale, and still pretty hard to tell what's going on here. Let's cut to the chase. Pretty much a gabbro. So here's another little outcrop of the rock, finger for scale, and at least it's not completely moss covered. I think my recollection is it was right about here that Chuck Lewis found and pointed out to me what looked to be a relatively large crystal of feldspar in here, and at that point we were both nodded and said gabbro. But can't find it. I mean, everything's covered with organic material. Hard to see anything. Let's see if maybe you can get a little bit of a view of some of the bits here. Whatever. Anyway, there we go. More rock. All right. Hey Logan. We're here at Alsea Falls. Probably won't be here all that long. It's just another waterfall. Basically the same kind of thing going on as at the last one. We've got some gabbroic intrusive rock that's holding up the stream. So effectively we can trace the subdued topography in the watershed upstream of here just to these two waterfalls. There may be another one or two in between somewhere, I don't know for sure. So relative to the last spot, the rock here seems to be quite a bit more massive. We're not seeing the kind of joining that we did at the last place, at least not right up here. There do appear to be some smaller blocks further down, but you can see some of the size of the blocks that had to be ripped out here over there. Pretty big.